Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 161. Please turn to page 161, and today is our lesson number 71. Page 161, problem number 66. In problem number 66, they talk about a certain school with the first grader, second grader, third grader, and fourth grader. So here it is. First grader, second graders, third graders, and finally the fourth grader, which I'm going to call the last grader. And the symbols that we're going to use in this problem so that it makes our life easier, the first grader are going to be the F, the S, the T, and the L. That's the symbol we're going to use. In the problem they tell us the ratio of second grader to fourth grader is 8 to 5. Second grader to fourth grader is 8 to 5. They also tell us that the ratio of first grader to second grader is 3 to 4. And then they go on to say, if the ratio of the number of third grader to the number of fourth grader, third to fourth, where can we put it? Third to fourth, which is our last, is 3 to 2. So they give us three of these ratios here. So I want to make sure that I did not mess them up. Second grader to fourth grader is 8 to 5, the first to second is 3 to 4, and then third to the last, which is what they call in fourth grader, is 3 to 2. That's my L. The question simply is, what is the ratio of first grader to third grader? That's it. They're looking for first grader to third grader. This is what they're looking for. They give us three ratios. We have to find the fourth one. It's not as nasty as it may look. Somehow we have to manipulate, and there is no right or wrong way of doing it. Different people will approach the same problem in many different ways. An exact same person actually would approach the same problem probably in one or two different ways, depending on their mood and depending on, if you give me the same problem in the morning, I might do it one way, and in the evening I might do the exact same problem completely differently. There is no right or wrong way of doing it. Our only goal is to somehow separate the F and the T by themselves. That's all it is. So let's see what we can do. I see the something has gone wrong here. Is this the second grader and the first grader, 8 to 5? No, it's not the first grader, it's fourth grader. The first ratio that they give us is second and the fourth grader, not the first grader, which is our L for the last grader. So we know that S to L is 8 to 5, and then I see T to L here. I see T to L here, and I see S to L here. If we were to somehow combine this one and this one, you can see we can get rid of the L, and we'll have S and T. Okay? S and T. And then finally, when we have the S and the T, we'll combine it with this one. We can get rid of the T, and we can get rid of the S, and we'll have our F over T. That's all it is. There are several different manipulations. Well, I don't know about infinite, but there are several different combinations that you can come up with. But that's what I'm going to do here. So the ratio of S to L and T to L. S to L is 8 to 5, and T to L, the third grader, the last grader, is 3 to 2. And now you can see the L cancels out, and you get S to T. And that works out to be, I shouldn't have started out like this because I need the room. I shouldn't have. Let's put it. Let's squeeze this here. T to L is 3 to 2, which is what we're combining this with this. And the question is, what is the ratio of first grader to third grader? That's the question. So let's continue here. 8 over 5, and then we take the bottom, we take the bottom fraction and we flip it, so it's going to be 2 over 3, and that gives us 8 times 2 is 16, 3 times 5 is 15, so 16 over 15. So that's s to t. That is s to t. Now what can we do? Ah, there you go. This one has f in it. Somehow we have the t, we have to look for something with an f in it. We have the t, we have to look for something with the f in it. Something with the f is this guy. So if we were to multiply, you have to decide whether you want to multiply or divide. Here we're going to have to multiply. So let's do that here. F s times st that we just found. St that we just found. This is s over t. If we were to multiply it, s will cancel out, and we will be left with f and t, which is exactly what we need here. So let's do that here. Let's do that. F over s. The first grader to second grader. Right here, first grader to second grader is 3 to 4. And second grader to third grader, we just found here, second grader to third grader, that's the ratio we just calculated. Where is my pointer? It's not a pointer actually, it's the chopsticks, but anyway, it's a pointer. Second grader to third grader, that's what we just found here, s to t, which is 16 over 15. Let's put it here, s to t. So first grader to second grader comes from here. First grade or second grade came from here, and s over t comes straight from here. So s over t is 16 over 15. That's it, we are done. Divide the top and bottom by 3, 3 cancels out and 15 becomes 5. Divide the top and bottom by 4, 16 becomes 4, and this 4 cancels out, and the answer is 4 to 5. The ratio of first grader to second grader is 4 to 5. That's it, we are done. That's all there was. Nothing to it. And like I said, there is no right or wrong answer. So which one is 4 to 5? I mean, I don't mean to say there is no right or wrong answer. What I meant to say is there is no right or wrong way of doing it. Whatever clicks in your mind, just go with it. Just keep, it's a matter of gymnastics. You have to keep flipping things and keep doing things until you get the two elements that are separate, until you manage to separate the two elements that you're interested in. In our case, we were interested with first grader and the third grader. What number was this question? 66. 66, and we found the answer is 4 to 5. That's E. The answer is E. That's all. Want to do one more? Let's do one more. Let's do the next one. Okay, I need to erase everything. And as a matter of fact, it will be a good practice for you to actually do the same problem in a little bit different way. See what happens. Try try the way we just did, and try two or three other different ways and see what happens. That's how we learn. The next problem is number 67. Number 67, it says m is the average mean of the first 10 positive multiple of 5. Oh, what a mouthful. N is the average of first 10 positive multiples of 5, and capital M is their median. And the question is again very straightforward. How much is m minus n? Capital M minus small m. In other words, what's the difference between their median and their mean? Now listen, when you take in this exam, and this comes through practice, there is no cure, there is no magic bullet to it. The only way you will get better at taking the exam, which is exactly what it is, it's a skill. Taking a standardized exam is a skill. GRE, GMAT, SAT, those are all standardized exams, and it's a skill that one acquires through practice, just like any other skill. And as you practice more and more, you begin to develop a feel for what sort of liberties you can take. Now here, they tell us that the average of first 10 positive multiple of 5, we have to figure out the average of first 10 positive multiple of 5. I don't know about you, but I'm not in the mood to figure out the average of the freaking 10 numbers. It will take forever. So I'm going to make it a smaller number. Let's pretend it's just 4. Now notice I did not say 5. Because here we're talking about median, and I just don't want to take a chance. Median, if you have 5 numbers, the median is right in the middle. If you have an even number of numbers, then in order to figure out the median, you have to take the average of the middle two. So I want to still keep that aspect, that characteristics, that flavor of the question. I don't want to take that away. So instead of taking the odd number, I took 4. So I'm not going to deal with 10 of them. Let's deal with 4. Whatever applies here will apply to a series of 10 numbers if you have, or whether you have series of 10,000 numbers. If you have first 10,000 multiples of 5, whatever we're about to do is going to be the same exact logic. It's not going to change that part. So let's have 5 numbers. So 5, 10, 15, and 20. 5, 10, 15, and 20. What is their average? Now this is something you have to know, and if you don't know it, you're going to have to actually do it out manually. But as long as the numbers are equally spaced, for example, let me give you a simple example. The average of 33, 38, and 43, because they are equally spaced, 33 plus 5 is 38, 38 plus 5 is 43, because they are equally spaced, if somebody asks you what's the average of these 3 numbers, well, the average is the middle one. The average of these numbers, 5, 8, 11, and 14, what's the average of these 4 numbers? Again, you have to realize 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14. They are equally spaced. Therefore, the average is going to be whatever that falls right in the middle. What falls right in the middle is the average of 8 and 11. 8 plus 11 is 19, so the average of these 4 numbers is 19 over 2, that's it. You don't have to go hog wild to actually do it out manually. The same exact thing is going on here. There are 4 numbers here, so the average is going to be whatever that falls in the middle. What falls in the middle is 12 and a half, because 12 and a half is 2 and a half from 10 away, and 2 and a half away 15 away. Or if you like, it's just 25 over 2. 10 plus 15 over 2. 10 plus 15 over 2 is 12 and a half. That is there. That is their average. Now what do you suppose their median is going to be? The median is something that falls in the middle. Again, since we don't have odd number of numbers, we have even number of numbers. Therefore, in order to figure out the median, we have to take the average of these 2 numbers, which is the exact same thing as this one. So the median is same as average. Here, the median is same as average. And since median equals average, or as they like to call it, arithmetic mean, since median equals the arithmetic mean, their difference is 0. The difference is big fat 0 because they are equal to each other. That's all. Let's go on to the next one, number 68. That's it, we're done. Number 68. We are given a set of numbers here. A is a set which consists of 2, 3, 4, and 5. And B is a set that consists of 4, 5, 6, 7, and 8. One number is to be taken from set A, one from B. Is picked at random. One number from set A and one from set B is picked at random. You're told that one number from set A and one from set B is picked at random. The question simply is, what are the odds that the sum of these 2 numbers that we pick is going to be 9? What are the odds? What's the probability? What are the odds that the sum of the pair is going to be 9? What are the odds the sum of the pair is going to be 9? Now, mathematicians of course will not write out like this. They would use symbols, and this is how we write in symbols. In symbols you will say probability that the sum equals 9 is what? So let's find out, shall we? very first thing we have to figure out is how many possible pairs are there. How many possible pairs are there? There are altogether 4 times 5 or 20 possible pairs. Why 20 possible pairs? Because if you were to pick 2 first time around from this set, there are 5 pairs you can make. 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. If you were to pick 3 from the first pair, there are 5 pairs you can make with 3. 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, and so on and so forth. If you were to pick 4 from the first pair, you can have 4, 4, 4, 5, 4, 6, 4, 7, and 4, 8. And if you were to pick 5, might as well finish it, you'll have 5, 4, 5, 5, 5, 6, 5, 7, and 5, 8. There are 20 different pairs. 4 times 5. 20 different pairs. Question is, how many of these 20 pairs, how many of these 20 pairs add up to 9? That's our question. That's what we have to figure out. Let's find out. That's very simple. Nothing to it. Let's find out. So, let's go systematically, okay? That's the key. Go systematically, don't go all over the place. So we're going to start with 2. 2, 4, that doesn't add up to 9. 2, 5 is 7. 2, 6 is 8. Aha, 2, 7. So that's the first one. 2, 7. 2, 7. And of course, once you have 2, 7, there is no point in looking at 2, 8 because 2, 8 is going to be more than 9 because this is 9. 3, 4, that doesn't add up to 9. 3, 4, 3, 4 is 7. 3, 5, 3, 6. Voila. 3, 6. And of course, there is no point in looking at 3, 7 and 3, 8. Let's start with 4, 4. 4, 4 is 8. 4, 5. 4, 5 adds up to 9. If you pick 4 from the first set and 5 from the second set, that will add up to 9. And once we have 4, 5, there is no point in looking at 4, 6, 4, 7, and 4, 8. They're going to be all more than 9. And then 5, 4. Finally, 5, 4. Now notice, 5, 4 is a different pair than 4, 5. These are different pairs. In 4, 5, what you're saying is that we pick 4 from the first pair and then 5 from the second pair. And in the other case, in 5, 4, it's an entirely different scenario. In 5, 4, we pick 5 from the first pair and 4 from the second pair. Those are 2 different pairs. So altogether, there are 4 possible pairs. 4 pairs add up to 9. Out of how many? Out of 20. Out of 20. Out of 20 possible pairs. That's it, that's our answer. So the odds of picking, the question was, what is the probability of picking a 2 pair whose sum turns out to be 9? The probability is 4 out of 20, which is same as 2 out of 10, which is same as 0.2. Well, that's your answer. That's our answer. 0.2, I think that's how they say it. As far as I remember, I think it was in a decimal. What number was this question? 68. I don't know why my page is turned to 170, 132. 68. There you go. 0.2. Answer is B. The answer is B. They give it in decimal, 0.2. But 0.2 comes from the fact that there are 4 pairs that add up to 9 out of total of 20 possible pairs. Therefore, 4 out of 20 is same as 2 out of 10, which is same as 0.2. I'll see you tomorrow, okay? Bye now.